All right, so let's get started. I know very little about what you're doing in the airplane world with Elastic. Why does Elastic matter in the airplane?
Yeah, great question. I'll kind of start high level and then dive into it, if that makes
Okay.
sense. So one of the things that we came across, so obviously from the beginning, I obviously support a lot of Air Force things. So I'm around a lot of use cases that involve aircraft, either indirectly or sometimes directly, like last week. So what we started to do, the team and I, was to really evaluate where specifically the customer is bringing data in, either into us already, maybe they're open source, maybe not, maybe it's into a competitive product, and really start to analyze the use case behind it. So not just the tech, like, what data is coming from where, but what is the real value that we would be providing? And so we started over the last couple of years. We've kind of had three or four things that we look at. And top of mind, and a really simple one to understand, is what we call operational energy. So the Air Force, much like many other end users out there, consumes a lot of fuel, a lot of energy resources go into running the Air Force. And you can think of it just strictly from the number of planes that are flown on a daily basis, right? It's millions of gallons of jet fuel every day that the Air Force is using to protect the nation, to train new pilots on new equipment. And so what we thought of was to say, okay, well, what if we were able to take in some of the data that's being originated from the aircraft, and more specifically from the aircraft engines and from some of the sensors that sense fuel flow within the engines. Maybe it has to do with a particular operational environment. Is less fuel spent bonus in the United States versus is more fuel spent per hour somewhere else in Europe or the Middle East or wherever? Are there regional considerations to the way that the planes are flown? And that also kind of ties into pilot training. No two aircraft are the same, no two engines are the same. So there will be some variances aircraft to aircraft. But one of the biggest differences that customers have told us they find is in the way that the pilot operates that aircraft. So part of that is, under direct control, right? Throttle and stick, you apply more throttle, there's more fuel. And some of it is just, maybe I need to get somewhere a little slower or faster, or maybe I'm out of fuel. Maybe I need to go and refuel somewhere. So the data and how Elastic plays into this is that the data that comes from certain aircraft, we can look at the amount of fuel that was burned. We can look at the flight time. We can obviously look at who the pilot was or who the crew was, if it's a multi-crew type of platform. Then we can look at the type of jet fuel. Not all jet fuel is the same. Sometimes when we have jet fuel that's processed overseas, it's a little different than jet fuel that's processed in the United States. So therefore, the engines perform a little bit differently. Not worse, not better, but just a little bit different in terms of efficiencies. And so this is where Elastic comes into play, is there's a lot of data that's generated on any particular aircraft per flight. Some of that data is contained in certain aircraft in basically a little black box, and it records everything that goes on, all of the sensors that are going off. So being able to take that data in post-flight into Elastic and then be able to do analysis upon these different factors, we can help customers such as the Air Force and such as many fuel consumers look at some of the parameters that are being used to measure the efficiency, and then obviously to potentially suggest improvements as to how that would operate.
What is there's so many interesting use cases on that, and I'm going to share a story real fast. When I was working in the airplane world with fuel, and that was from a cybersecurity perspective, because somebody put something nefarious in that fuel that's obviously bad, right? That'd be very, very bad. And there is a very impressive network as we were talking to these logistics people for this fuel that like they they lock it up on site as soon as that fuel is set up, and that lock can only be opened when it's at the actual location. Before it's placed into the fuel pit is tested by a chemical engineer to make sure that the fuel is good, that this new set is not going to affect the current set in there. And then they pour it in there. So it's tested. And then also that trip from wherever it was, the manufacturing, the refinery to the actual pit, that truck is monitored, and if it goes off course for a little bit, if it goes in an odd location, local police are dispatched to it. I mean, yeah, like we talk a lot about cybersecurity, but really at the end of the day, it's that airplane that's over enemy soil. Is it safe or not? And that fuel is obviously as important as any computer on that system. And so connecting this fuel cost component to the fuel cyber component, being able to assess full view what's going on with that aircraft, I could see there's a lot of similarities to that data set right there.
Yeah, you nailed it, Nathan. So all of those things play into the supply chain, right? The fuel supply chain. How are you processing the fuel? How you get transporting it? How are you loading it? And here's the thing, and this is true in my lawnmower right this weekend. So I couldn't start my lawnmower because my gas had too much moisture in it. I hadn't, I put the gas in from last year, and it doesn't use much gas. I don't have a big lawn, so I usually refill my fuel container once per summer. And that fuel had sat there and sat there and sat there for months, collecting moisture, right? Condensation and temperature changes. So you're absolutely right. The security of the fuel getting there, and then the handling of that fuel once it's loaded on the aircraft. The easiest way to contaminate fuel is to dump some water in it. It doesn't have to be any, major chemical, but if you start to add water to fuel, here's the problem. Typically, and I've experienced this in a different world, in a different life, is that because of the way that the fuel tanks are integrated in an aircraft, right? So in a car, right, you put gas in your gas tank, that's it. You got one tank typically, and maybe you're a truck, but let's just say you're in a car. Typically, you have one gas tank. In an airplane, especially one of size, you're going to have 4, 5, maybe a dozen different fuel tanks. And so if it's all the same fuel, guess what? And if that fuel has moisture, now all of the fuel that's feeding each of your engines, let's say it's a twin engine plane, twin engine jet, now both engines are susceptible to having a problem, not because the engines are bad, but because what you're feeding the engines has been contaminated, either maliciously or accidentally. So you're absolutely right. The security of that fuel from start to finish, where does it start? Where does it finish? And how is it burned by the plane? All of those things, a 1% difference in fuel burn for a wing, right? Just a squadron of aircraft, not even the entire Air Force, just like a squadron. That's going to be a decent amount of money at the end of the year. More than likely close to $1 million, depending upon the plane, depending upon how they fly it, of course. But jet fuel is expensive. It's like $7 a gallon. I don't know what the government pays for it, but it's about $7 a gallon. So multiply that by thousands of gallons. And if you're saving, for argument's sake, 20 cents on $7, that doesn't sound like a lot up front, but you multiply that out, that gets real expensive really quickly. Yeah.
When I think of Elastic, I think of unstructured data. When we are talking about this fuel usage, can you think of any specific example of Elastic and the unstructured data, and how the unstructured data helps the analysts assess fuel usage?
Interesting. I would say that really when you're looking at unstructured data and the types of things that would be in that data. So It might just be a stream of data coming out from a fuel pump, right? Maybe it's analog to begin with. Maybe it's digital later on. Maybe it starts as digital. There's different ways to measure it, but it's not really in any structured format, right? It's just a number that's coming across from a sensor. So how do you take that into Elastic? Pretty straightforward there. Once we understand what's being measured, obviously the data at some point has to become digital for us to really operate on it. But from that point, we can take it into Elastic. We can normalize that data and make it analyzable, if that's a word, within the platform. There's many different things that would feed into that. I think in this particular use case, let's just stick on fuel, for instance. So the chemical composition of that fuel, right? At some point, there will be sensors, coming to your point earlier, that look at how that, where that original oil started, because it's going to be starting from oil, what the refinery process along the way is. Most of the time, that's not like, it's not a Word document, right? It's not a PDF. That is typically sensor data. And yes, you can aggregate that sensor data into something more structured. Elastic can operate on either. So if we have sensor data that we understand or can help the customer to understand, then we can take in from kind of base level sensors. Additionally, if they are aggregating it into, say, semi-structured data, then we can operate on that too. It's just a matter of actually getting that data, understanding what the value we're trying to derive out of that is, normalizing that data in the platform, and kind of going from there.
Can you give... Oh, I'm trying to think of, like, I don't want you to share specific examples. I don't like exact examples, but can you give like a little more detail to a specific example? At the beginning, you did pretty well, getting pretty broad. Would you feel comfortable getting even more specific to an example? If not, it's okay.
Sure. Give me a hint there. Point in the right direction.
So like you're talking about the usage of fuel, and your way you're talking about it almost sounds like you've talked to actual customers about this. And while I don't want you to talk about the specific customers,
Okay.
yeah, like what excites them about Elastic? Why are they coming to you for this?
Yeah, got it. So I think that I'll mention one of our products. So Logstash is an Elastic product, and it has the ability to basically dissect any type of data that we need to look at. So there's a kind of, when customers first talk to Elastic, a lot of times we are talking about security or observability or search. And they say, okay, well, how are we going to get our search data in? We kind of go through those discussions. But from a kind of, in this instance, from a jet fuel perspective, it's really a little bit different. So one of the reasons that they turn to Elastic is because we have a very cool tool called Logstash that can parse almost any digital data that I've come across since I've been with the company. I'm sure there'll be an example where that isn't the case, but so far in several years, that's not been the case. So flexibility up front in terms of data ingest, Elastic provides a relatively easy way to get started with Elasticsearch. If they can use cloud, fantastic. Maybe they can, maybe they cannot. A lot of our customers are on-prem for obvious reasons. And then the ability to do very quick analysis. So we have a number of different interfaces within the product that you can just basically look at the raw data. Kind of depends on what you're looking for and looking to, again, get that value out of it. What question are you trying to answer from the data that you're bringing in? Is it, how do I make this engine more efficient? Maybe. Is it, how do I lower my cost of transporting that fuel from one place to another? Maybe there's some efficiencies in the volume of fuel that's moved at any one time. Sometimes moving less fuel more frequently is more efficient than moving a lot of fuel less times. And there's different ways to look at that.
I've heard from this that's why there are tankers that are out in the sky, because it costs so much to bring an airplane back up into the air that it's just cheaper to keep that tanker with an absurd amount of gas in it, just sitting there, and one plane comes in and connects, and the next plane comes in and connects, and no one ever has to land. So yeah, I see that completely.
No, you're absolutely right. Takeoff and climb consumes a lot of fuel. And in addition, there's a time factor to doing all of that. So not just are you spending the fuel, but you're spending extra time when you could be orbiting the tanker and getting some gas and then kind of moving on. And just as a quick aside, I happened to watch a video yesterday about the Falklands War in 1982, and the number of times that a particular plane called the Vulcan had to refuel from Ascension Island all the way down to the Falklands. It was 18 times that they had to refuel, and they never landed. They landed one time. They took off once. They flew south. They got refueled 18 times along the way before they, landed back where they started. I thought that was pretty phenomenal.
It's cool.
But in that path, right, there are probably times, and there's no perfect planes, there's no perfect pilots, but you can start to look at nominal ranges of refueling times, right? Sometimes in bad weather, right? Sometimes you don't have a choice but to fly through turbulent air, just like as a passenger, right? Pilot tries to avoid that, tries to make you as comfortable as possible. Typically, they announce all that stuff, but guess what? You're still flying through that turbulent air. Guess what? Same thing with, our air forces. They don't get to always choose where they refuel or when. So we don't talk a lot about, or you don't typically think of refueling at night, but that is 100% part of, operational missions. Usually we see tankers on YouTube refueling during the day, right? Obviously, because it's daytime. But there are just as many, and I would say at times, at interesting times of conflict, there are more refueling at night. That night refueling is going to consume more fuel from the pilot and from the tanker just hooking up because it's at night, right? It's a different environment. It's a whole different world. And, even though you got your night vision and everything else, it's still dark outside. So that can make it more challenging. And just understanding that, right? Not even a sense that you would try and make it better, like you'd want it to be better, but the question you're trying to answer might be, what is the delta between day refueling and night refueling? So that for mission planning, I can go, okay, well, this aircraft that had to refuel 18 times, guess what? 10 of those times was at night. So instead of just an average number of, let's say, just for argument's sake, I need 100,000 pounds of fuel, whatever it is, for a day, and just say, oh, well, 18 times 100. No, might not be that. It might be, more than that, because you have to account for adverse conditions, turbulent air, nighttime flying. These are, thunderstorms, right? You might be flying through a thunderstorm just because that's where you got to do it. Over.
Yeah, all the weather, and it would probably be different for all the weather things. Let's transition for a little bit. Manufacturing. I think you wanted to walk. I'm guessing that was a topic you wanted to talk through as well.
Yeah, for sure.
IoT as well. But yeah, like where does Elastic fit in that world? What is
Yeah, so from a manufacturing perspective, I like to think of it as supply chain, right? So as you make an airplane, there are many things that go into that, some of which are on your shop floor, meaning you've got technicians there putting all the parts and pieces together, doing quality assurance. All of that is data that is being collected by the Airbuses of the world, Boeings, Lockheeds, all of the above. It's a very tightly controlled environment because it's an airplane. And you need to have very tight tolerances on many of those things, and they're constantly being measured. That is a constant part of manufacturing today, is how well are you manufacturing this part? And how well does part A match with part B? Or how do they go together? Do they go together where we don't have to do any more fabrication? Or do we have to put them together and then do more sanding and, welding and all the things that kind of go into that? All of that is being measured. And that's something that Elastic can help with. That data has to go somewhere. Typically that is structured data because there are formats that the tooling that a manufacturer would use, it's all digital, right? The tooling is computer controlled. Yes, there's a human there to kind of do overwatch on it. But when you're seeing the robot arms come in and do welds on this section of aircraft, all of that's computer control, and there are reports, metrics that are driven after the fact. Part of it is how well is that manufacturing process occurring, just in and of itself. Part of it is, these tools are very expensive, right? These are $1 million tools, $1 million robots, basically. So how well is your robot performing? What is its time between just for the tooling itself? And this is true, obviously we're talking about airplanes today, but this is true in many mass manufacturing things, whether it's appliances or cars or other things. Obviously, as you get more and more complex, like to aircraft and spacecraft, you get tighter and tighter tolerances because your risk factor for a refrigerator going bad is less than your risk factor for an airplane wing coming off. So the metrics, so the importance of gathering those metrics and the importance of being able to do predictive analysis on your manufacturing process, very important. How does Boeing, right, predict how many workers they'll need to work the assembly line next year when they get this new order in? What is that based upon? What is the new type of tooling that will be required for a different design of landing gear? All of those things are, so those are all of kind of the airplane parts. There's data behind each of those, especially when it comes to aircraft, spacecraft. It's just a very important thing. Elastic can take that data in and help customers kind of explore the efficiencies to be gained.
What what questions am I missing here? What are some things that I haven't thought about so far? I have one.
Go ahead.
Let's talk about aircraft and cyber. And when we're talking about aircraft, I mean, this could allude to any major machine, expensive, very important machine. Grabbing the cyber off that aircraft historically has been difficult because if the airplane works, they don't want to make any changes. And you often will deal with very operating systems and systems on there to grab that data. What are we able to do at Elastic to deal with even like we respect that people don't want to make changes to their system. What can we do to still provide cyber in those circumstances?
Yes. Cyber on an aircraft can be a couple of different things. I liked your example earlier of basically inserting code into different parts of, maybe chip design is one vector we've seen very often where, a nefarious actor will get involved in the supply chain, kind of going back to a supply chain thing here, and they will modify, some code on the chips. Now, it doesn't mean that they're trying to crash the aircraft. Sometimes they're just modifying it because they know that they can then read it afterwards. And I won't get into all of that, but what Elastic is able to do is to look at some of that data that's coming across. Whatever data we're given, we can police against. Sometimes it's policing against logs, where we're just taking log information in and saying, okay, here's what we're seeing. Here are some of the thresholds that you asked us to report upon. So, for instance, maybe you lose your GPS signal, for argument's sake, at 10 times per hour. Let's just say that that's the case, that you kind of go out of lock 10 times per hour. Maybe that's an acceptable threshold, maybe not. It seems like a lot to me, but let's just say that it is. Next flight, you can barely get it to sync at all. So is that an attack? Well, you don't really know right away, but By being able to gather that data into Elastic, you can start to do this type of analysis on where did that lock go out? Were we flying in a particular part of the ocean that day? Or were we flying over a particular country or area of the world where we started to lose sync? Was that part of it? Maybe it was just a bad GPS unit, because that absolutely happens. Maybe my map didn't get updated. So you kind of have to start in reverse and say, okay, well, what is the highest risk that we have for our avionics suite? Let's just say avionics suite. Well, a lot of it might be GPS based or location based, because there's multiple ways to figure out your location besides GPS. By knowing what you're looking for, say GPS lock, let's just say that that's a thing that we're trying to find out, then we can go back and say, okay, well, what is all of the data that would feed that to tell us whether it's out of lock? Well, you're probably going to have some type of source from the GPS transmitter itself, probably from the receiver. And in more sophisticated aircraft, you're going to have a separate timing signal with a time-based controller that's, like an atomic clock type of thing. So you're going to have an internal reference, you're going to have a satellite reference, and you're going to have an independent time source to then understand if there's differences in the timing, right? Because the GPS timing is very, very precise, down, in some cases down to the nanosecond as to what's being measured. That's how you get more precise with GPS, is you lower your timing thresholds. Large timing thresholds mean that you might be within 20 feet of somewhere. Lower time thresholds mean that you might be within, 20 inches of somewhere. Those types of things, identifying what is the highest concern for the program within that aircraft, and then figuring out what data actually feeds to that, and then where Elastic would come in is ingesting that data and setting up those thresholds, setting up machine learning jobs on trending information. So if you have, let's say that you had 100 flights worth of data for 100 different aircraft. Now you can start to do measurements across your fleet of aircraft. Oh, well, it's not just this one aircraft that's having a GPS problem. It's these 5 aircraft, and they just went through an inspection. Well, maybe there's, it doesn't have to be malicious. It might just be that the airman that was servicing those GPS units needs more training, or missed something, or missed a library or something like that. But guess what? By missing that update, that becomes a potential vector for an adversary, because, again, there's no perfect maintenance records that go on an aircraft. They do awesome jobs, but there's always things that are missed. And we can see that in the news today with, many manufacturers. Boeing is recently, but it's just the same across Airbus. It's the same across any manufacturer, really.
Mm. Tell me what else? We're getting close to the end here. What other topics have we missed? What are some things we need to talk about?
Let's see. We hit supply chain, we hit manufacturing, we hit operational energy, we hit cyber. I guess the one thing that, and we haven't really talked about this, but if I were to look at Transcom, for instance, the logistics of flying things around the world is a very complex problem to solve. Because Transcom is multi-service, not only do they have their own stuff to manage, but they are now trying to divvy their resources up between all of the services. So that's a challenge, both in the type of supplies, resources that they have to do that, as well as tracking the goods and the contents on those aircraft to the different places that they have to go. So, for instance, you might have, I'll say the Army this time. So the Army might have a need to have, for argument's sake, 20,000 different rations, meal rations, delivered to some area overseas. Let's just say it was Italy. I need 20,000 rations in Italy. So, okay, well, How are you tracking that? Because just like with fuel, you want to make sure that your food supply stays intact, right? So, what are the concerns with food supply? Well, obviously, normal contamination and decay, that's just normal in any food delivery. You're going to have a certain percentage that's just not going to make it or was already kind of bad before it got on the plane. That's just the reality. You're going to have hopefully most of it make it intact. Where, was that a secure chain of how that food was either processed in the beginning, packaged, aggregated into a container or into a pallet, and then put on the back of an aircraft? So those logistics of moving food, there's an air transport part in there that can get complicated because now you need to get this food over to Italy and maybe you can just do it on one aircraft. Fantastic. Well, now you're tracking that food supply over, and what happens when it gets to the other end? Now you have to say, okay, this aircraft delivered this food made it to where it's supposed to go. Those logistics all can be tracked within Elastic, and we're doing this for many customers. I think Bosch in particular were doing something very similar. It's not food, but it's a very similar supply chain thing where we're tracking the logistics of how different customers of ours actually receive goods, how they put them together, and then when they deliver it to their customers or to their end users, all of that data can reside within Elastic, and you can literally see from start to finish, either on a very nice, fancy display, or you can get right into the numbers and characters of that to see the exact raw data of when an airman or whoever basically scanned it, just like they do at the airport, right? It's all skewed. So those containers all have SKUs on them. So when you scan it, it will pull up on his reader. Yes, this is food parcel A and it's destined for London, England, or Italy in this case. And then on the receiving end, same thing, just like a baggage handler at the airport. They got another SKU reader. They read that. Yep, we received it. Oh, you know what? We're missing, we're supposed to get 20,000 rations, but we're missing 5,000. Like, where could they have gone? Well, we had to refuel somewhere along the way where we actually had to land and refuel. I wonder if somehow those rations kind of got off base there. Anyway, short answer, Nathan, I think, is the logistics of moving things around via air transport is part of what Elastic can help analyze and make better.
Awesome.